Here we go. We have a question, not a subset sum. So you have given a sorted array of positive integer, and our task is to find the smallest positive integer such that it cannot be represented as the sum of elements of any subset. So in this test case, we can make 1, we can make 2, we can make 3, we can make 4 by selecting this and this, we can make 5, we can make 6. So 7 is the smallest positive number that we cannot make. In this test case, 1 is the smallest positive number, so output is 1. So let's try to build the approach. So in this test case, we can make 1, 2 and 3. So here the summation is 3. The next number, we know it's in increasing order. So if the next number is 2, if the next number is 2, can we make 4? Yes. So our next number is 4 that we want to make. If the next number is 2, if here the number is 2, we can make 4. Yes. If the next number is 3, we can make 4. Yes. If the next number is 4, we can make 4. If the next number is 5, we cannot make 4. So let's assume the next number is 3 itself. If the next number is 3, we can make 4. Okay. So now we can make 1, 2, 3, then 4 by selecting this and this, 5, then 6. So till 6 we can make, the summation is 6 now. The summation is 6. The next number that we want to make is 7. So if the next number is 3, can we make 7? Yes, we can make 7. If the next number is 4, can we make 7? Yes, we can make 7. If the next number is 5, can we make 7? Yes. If the next number is 6, can we make 7? Yes. If the next number is 7, can we make 7? Yes. If the next number is 8, can we make 7? No, we cannot make 7. It means till 7, if the number is till 7, we can make the sequence. If the next number is greater than that, we cannot make the sequence. So how do we get the number 7? Because till now the summation is 6 and the next number should be less than or equal to sum plus 1. If let's take this number I. If the number I is greater than sum plus 1, if the next number is greater than sum plus 1, we cannot make this sequence. So we will return 1. Oh, sorry, not 1 means we can make the number till 6, but sum plus 1. Here the sum plus 1 is 7. If the number is greater than that, means 8, 9, 10 or whatever else, means we cannot make 7. 7 means 6 plus 1. 6 means sum plus 1. So sum plus 1 we cannot make. So the smallest number we cannot make is sum plus 1. Else we will include that number in our summation. So let's suppose the next number is 6 itself. Next number is 6 itself. So 6 plus 6 is 12. So now the next number is that we want to make is 13. Next number we want to make is 13. If the number is 6, can we make 13? Yes, we can make 13. If the number is 7, can we make 13? Yes. 8, yes. 9, yes. 10, yes. 11, yes. 12, yes. 13, yes. If the next number is 14, we cannot make 13. So we just want to return sum plus 1. Sum is 12 and sum plus 1 is 13. So this approach will work. So let me try to apply the same approach on a different test case. Let's suppose we have this test case. Till here our summation is 7. So you have to believe you can make this sequence from 1 to 7, all the numbers. So you can make 1, 2, 3, 3, then 4, then 5, then 6, then 7. You can make the number till 7. The next number we are interested in is sum plus 1, means 8. If the number is 4, can we make 8? Yes. If the next number is 5, if the next number is 5, can we make 8? Yes, we can make 8. If the next number is 6, can we make 8? Yes. If the next number is 7, can we make 8? Yes. If the next number is 8 itself, can we make 8? Yes. If the next number is 9, can we make 8? No, we cannot make 8. So 8 is the largest number that we can afford. If the number is greater than that, if number I, element I, this is the element is greater than sum plus 1, sum is 7 and 7 plus 1 is 8. If the number element is greater than sum plus 1, we cannot make sum plus 1, we cannot make 8. So just return that number. Else just include the number here. So that's about the approach. That's the algorithm that we want to, that's the code that we want to include in our for loop. So how do we start? So let's suppose we have a single element. The first element that we want is 1. So let's take summation as 0. So if the element, here the element, if the element is greater than sum plus 1, we cannot make sum plus 1. Else just include this number, sum plus equal to I. Here if the number is 2, we cannot make 1. If the first element is 2 itself, we cannot make 1. If the number is 1, means sum plus 1, it is not greater than sum plus 1, means we can include this number in our summation. Okay, so that's how we will start. But how do we end? So let's take this example, 1, 2 and 3. So here the summation is 0. This is the number summation plus 1. It is either smaller than or equal to sum plus 1. Yes, so we will include the number. Next, this number is less than or equal to sum plus 1. Include that number. So now our total is 3. Next, the number itself is smaller than or equal to sum plus 1. So include that number. Now we are get out of the while loop or for loop. The next number we can make till 6, but the next number 7 that we want to make, and 7 we cannot make. So just return sum plus 1 outside the for loop. So that's about this algorithm. Let's try to code this. First we have sum variable, then we have for loop. If the number is greater than sum plus 1, means we cannot make sum plus 1, else just include the number, and at the end return sum plus 1. So that's about the code. Let's give it a try, and let's talk about time and space complexity. It is pretty clear that the time complexity is order of n and space is constant. So the code is given in the description box. With this, we have successfully solved this question and also meet the expected time and space complexity. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.